Hi, this is Matthias from Transsolar. With me there is Clara.
Hello everyone.
We did a lecture for the NUST and unfortunately the recording was not working, so therefore we prepared this small overview and we are just explaining you briefly what we were actually showing to the NUST in October, and the topic of this lecture was Solar Analysis Introduction. And this is part of the new Transsolar World Academy that Clara is doing, is organizing, and with some support of me for this lecture especially. And so let's start giving you some insights on our lecture. We started basically just with daylighting and with the meaning of daylighting in terms of physical background, what is actually electromagnetic wave, but also what is daylighting meaning in terms of perception, how does our eye function, and how sensitive is actually the human eye to different light intensity, because visual comfort is something very important for our well-being, but also the solar radiation impacts the energy performance of our buildings.
Okay, now we go through the sun analysis, meaning that we will analyze how to read the sun and what to do with when we know exactly the position of the sun. So if we look out of our window, we will see that the sun has different position in any moment, and even if we are at the same time from Stuttgart, where we, together with Matthias, we are seated, and from Bulawayo, the sun will have different position. This is because the sun position is extremely related to the observer position, and since we are in different location around the world, the sun appears with different coordinates. Those coordinates are defined as azimuth and altitude.
So this is depending due to the fact that the Earth's axis is tilted against the sun, which leads to different angles in summertime and wintertime, and this is kind of different everywhere on the globe. You will experience different sun passes.
Yes, exactly. So that's why we normally use 3 different coordinates to define the position of the sun that we can read in different charts. This is one example. This is called sun path, and this is a 2-dimension representation. You can see that the sun path has a different shape for each single different position on the globe, and from this chart you can see all the information that you need. According to the lines of the date and the lines of the hour, you will see which is the altitude of the sun and the azimuth. For example, here we are now seeing the 12th of the 21st of December. There is another way to analyze the sun path, again in a 2-dimensional way. This is the Cartesian sun path, in which we have the azimuth information on the horizontal axis and the altitude information on the vertical axis. This is exactly the same information, just in another way of representation. Again, another way to study the sun position is through a 3-dimensional representation. This is extremely useful when, for example, you need to analyze the context, how this influence your buildings, or how different facades of the same buildings react to direct sun in different moments of the day of the year. So now we see a long sequence of picture for the 21st of October. That was actually the day of our lecture, and one for each hour. And we can see the impact, for example, on the shadow, how they differentiate according to the moment, to the time. There are plenty of tools, of free tools that you can find online, and then this is just a comparison between the longest day and the shortest day of the year in Bulawayo, in which you see the different shape on the ground. And as I was saying, there are plenty of free tools online that you can find for free, and this is just one example on the Andrew Marsh tool.
So next we were talking about the solar radiation and how kind of the electromagnetic waves from the sun are reaching our Earth's atmosphere. generating kind of this distribution curve of the visual light, but also the infrared radiation. The radiation can be differentiated in between direct and diffuse and reflected radiation. We were talking about the albedo, kind of the reflectivity of a surface, which, for example, for snow would be a very high number. And we were also talking about the kind of the issues of reflections, kind of what type of reflections you can have from a building, and how we would perceive it, just as an example on this high-rise. So we are looking at the sky. There are different sky models representing the different statuses of the sky, being overcast or clear. This can be transferred in a computer model for our simulations, and just showing the different distribution of the radiation throughout the whole hemisphere. And of course, these different sky conditions would lead to different radiation intensity, which is also, the radiation intensity is also coming from the way how the sun needs to travel through the atmosphere, causing that everywhere on the globe it has a different intensity. Now comparing the annual solar radiation for our two cities, Stuttgart and Bulawayo, you can see that the solar intensity on the different orientations is usually significantly higher in Africa, due to the position on the globe. And if you're looking on this radiation charts also for a specific day, you can see that there is kind of a peak intensity during midday with a very high solar intensity if the sun is shining. But you can also see that if, for example, a cloud comes up, that this solar radiation will decrease because the clouds are blocking partially the radiation. So here also a different representation for this. And if you add up all those hourly values, you would come to kind of an annual chart of solar radiation, which would look like the diagram showed. And of course, this has a big impact on the building, which were just explained briefly. Next, also we showed some analysis tools, which is, for example, the view from sun analysis, which we are using in the office, which means we are putting a camera on the position of the sun. And we were using this, for example, in a project in Africa, to evaluate the performance of a fixed shading element, which is a clay tube. And the question was like, how deep must this element actually look like to perform as a good shading system? And we were using this view from sun analysis to evaluate at what hours actually you need what kind of depth of those clay tubes to provide sufficient shading. And with this analysis, we could showcase the architects what is the optimized depth to avoid to reduce also the daylighting, on the other hand, too much. Another assessment methodology is to calculate the sun hours. So we can take a building geometry and simulate over 1 day or 1 year the different facades, how much sun or how long actually does the sun shines on a certain facade or roof area. And we can also use this method to investigate the solar radiation, for example, in kilowatt hours, to analyze the need of a shading device or the performance of a PV system on a facade or on a building roof. And the last method I would like to show is, or that we did show, was a thermal simulation, which is a complex dynamic simulation to assess the temperature comfort inside of a space of a building. And we can show here with different methodologies, for example, with a window-wall ratio or with a shading device, how the temperatures inside of a building will change. Next, what we did is also that we showed different shading strategies for buildings, kind of how to protect against the sun, we were showing negative examples where it doesn't work as it should be. And then we just showed different examples of how a shading device could look like, operable shading devices that might be put inside of a building, or kind of rotable lamellas that have also acoustic effects. There are plenty of different methodologies, for example, fritting on a facade, or putting metal elements inside of the glazing units, which also could be an electrochromic glazing. We explained about fixed external lamellas, brise-soleil facades, or operable lamellas. And for example, also that have a certain light redirection capability. And if you need some more wind protection, then, for example, roller shutters would be a good option. And we showed examples from Transsolar project where a shading system was kind of custom made for the specific architecture. And we even compared the different shading devices in terms of performance. That's it, guys. I think from there the lecture was over. And
we just presented 2 exercises for you. If you still have some questions, don't hesitate to contact us. Thank you very much, and hope you enjoyed.
Yeah.